Hello friends, in this session we are going to start with Java 8 new features. And what are the Java 8 new features and what are all the topics we are going to see in this session. Not exactly in this session, and we'll just start here and we'll continue till so many sessions. And Java 8 is having so many features, and we're going to see the most important features which you're going to use every day in your application. So say Java 8 new features. And what are the topics we are going to cover here is the very first one will start with we're going to start with the most important topic, and which is very useful nowadays, that is Lambda Expressions. Lambda Expressions. And the next topic we are going to see here is functional interfaces. Functional interfaces. And then we'll see the third is some predefined functional interfaces. Predefined functional interfaces, like you have predicate, you have by predicate, then you have consumer, same way again by consumer, then you have function, and like this so many other built-in predefined functional interfaces, and the use of those also we're going to see in throughout this session. And the next we'll see you have one more here, so it is supplier, like this, right? Some other also we are going to see in this. And the next we are going to see the fourth is method reference and constructor reference, and it is actually the scope resolution operator, what you can say. And then fifth one we're going to see here is default and static methods in interfaces. Then next we are going to see for each method, it is for each method, that in iterable interface, and then next we are going to see number 7, we're going to see Java stream API, and then we'll see concurrency or collection API improvements. Collection API improvements. Next we'll see Java IO improvements, and then Java time API, and then we'll see miscellaneous core API. improvements, right? So these are the topics we are going to see in Java 8 new features, and that is going to take some 7 or 8 sessions. So what are the topics we are going to see in Java 8 features are, first one is the Lambda expressions, right, which is the very important one first, and then we'll see functional interfaces, some predefined built-in functions which are like predicate or by predicate, consumer by consumer, function or supply, or some other built-in functional interfaces. Then we'll see the method references and constructor references, which is the new concept completely in Java 8 features. We'll see default and static method, how you can use in interface, for each method in iterable interface, and Java Stream API improvements, collection API improvements, IO improvements, time API, and some miscellaneous core API improvements, right? So these are the features we are going to see in this Java 8 new features. So first one, we'll start with Lambda expressions. What is actually a Lambda expression and why it is so important nowadays? Lambda expressions. So what exactly a Lambda expression is actually, right? So Lambda expression is actually a function and which is not having any name and which actually does not belongs to any class, right? Lambda expression is just a function and it is anonymous function. You can say it is anonymous function and which does not belongs to any class, and which does not belongs to any class, and which is not having any name, right? And you can say lambda expression is just like a block of code which is assigned to a variable, or a function which is assigned to a variable. For example, if I say int x is equal to 10, then 10 you are assigning to x. In the same way, say string s is equal to some abc, then what you are doing is abc you are assigning to s1, right? Or if you take a an object of some type, say abc is a class somewhere, or say hello is a class, hello h is equal to say new hello, right? New hello, and that it is an object actually, right? Object, and this is just a variable, and variable is having the address of this object into this, right? Same way, when you declare some variable and inside this variable you store a block of code, right? Some block of code you are storing here, then this is called as an expression, or this is called as an lambda expression, you can say. Or I can say something like this, say I have a variable, some a is a variable of some type, and I want to store here say public static, and say void some m1 function, and this is the function implementation. Here you have some statements, and those statements you want to store into this a, right? So normally what we have seen is we cannot store any function or any block of code into a variable, but lambda expression does that. A lambda expression means a block of code you are going to assign to a variable, or a function you are going to store into a variable, and you can use it later with this name when you need that to use, right? So this is the main goal of lambda expression. A lambda expression is nothing but a anonymous name like this, right? A block of code which is not having any name, right? An anonymous a function, or a anonymous function, or a block of code which you can assign to a variable. So this is actually the lambda expression is, right? Next, so normally I cannot do like this, say this is a variable, it is a variable a, and which is going to store a function, and the function should not have a name. So this operation actually we can do is we can take it like this, say say I have a some variable of some particular type, and I want to store a function in that, say one variable here, some variable, and it has to store a function. So function I'll give here a modifier public, a return type is void, and function name, some function name, say show info, and here is the parameter list, say params, and here you give the block of the function, right? So this is a function I'm trying to store, or a block of code which I'm trying to store into a variable, but actually which is not possible. But the same thing you can do by using a lambda expression. And how it is when this is a variable, and when you want to store a block of code, then you no need to mention the what are the things you no need to mention is, you should not use any modifier for that, you no need to mention the return type, you no need to mention the method name, and you have to mention these and the block of code. And one extra small piece of code you have to write here, it is this operator you have to use. Now this becomes a function which is not having any name, and that is going to be assigned to a variable like this. So now it is becoming, say, a variable is equal to, this is a parenthesis here, it has some params, and this is the operator, and from here till this is the this is the expression. This is a lambda expression, right? A block of code you are storing, or a function you are storing into a variable, and which is not having any name actually. And if you have the parameters, you can supply the parameters here. So the syntax of the lambda expression, you can say like this: a block, and here it is parameters are optionals, params, and this operator, and from here and till this I can say this is the body of the function, right? So this is a complete lambda expression. This is the complete lambda expression, and this expression you can store into a variable, something like this, variable something like this, right? So this is like lambda expression. For a small example, we can say like this, say you have a, I'll take a interface here, and say the interface is something like this. Interface, some in is an interface, and in this I have a method, say void m is a method with some parameter, say string s is a parameter, and it should not have a body because this is a parameter, and the method is by default abstract and public. Now normally when you create an anonymous class for this, or if you want to create an object for this interface, then you cannot do anything for this, and you cannot create an object for interface, because interface cannot be instantiated. So what I can do is I need to take a class, say class A, and inside class A, actually class A implements say interface, right? Then you have to implement this abstract method in this, so you have to say it is public void m with some string type s, right, with the strings type s here, and here you write some implementation. This is how you can do it, and you can say here, say in1 is equal to new of a, and you can call the function, say in1 dot m function, you can call like this, right? Or another option what you can do is you can take a anonymous in a class, like in2 is equal to new in of. So from here until this is the anonymous in a class, and inside this you have to implement public void m is the method, and here you have to give the implementation of this method, right? So now you can say here in2 dot m function you can call. right? So this is by using a separate class you are implementing the interface and implementing the methods in that class and creating an object of this class and calling the method, right? Or second option, what you can do is you can take a anonymous inner class, and inside the anonymous inner class you are implementing this function and then you are calling the function here. Now the same operation what you can do is you can take a variable of type in3 is equal to, then the method which you are going to implement, that is m method, the method only directly you can store into this reference variable, and in that case, as we have seen the signature, only you don't need to mention the method name, or the modifiers are also not required. What you can just say is, so this is the variable string s, and from here till this and the termination, say this is the implementation of the method you are writing. So sorry, here you missed some point. It is having actually this, and from here till this is the body of the method, right? So this complete is one anonymous method or a block of code, or this only is the lambda expression, and this method implementation or the method is actually going to store into a variable of type interface, which is in3. But you don't make a mistake here. Don't think that this is a anonymous in a class. It is not anonymous in a class. Anonymous in a class is this, and at this point it is creating an object of anonymous in a class, and that is going to store into in2, right? Anonymous in a class object is going to store into in2, and in this case it is not the anonymous in a class. This is the method, anonymous method, or a lambda expression. That lambda expression itself, or the block of code, is going to store into in3. Right, now you can call the function something like this. in3 dot m is the function. This is the function execution, right? So first case, when it is having an interface and you have a method, then first what you can do is, first implementation, we have created a class and implement the interface, method is overridden, and then we have created an object of that implemented class and we have called the function with this. Then we have reduced the code little bit here in the anonymous in a class, and here only we have defined the class at this point, function implemented here, and then we are calling at this point. Now in lambda expression, what we did, we have not created any object of the class, or we have not created any class itself, no anonymous in a class, nothing. Directly the implementation of that method we have stored into a variable and calling the method when we need. So this is a lambda expression. A lambda expression is nothing but a block of code or a function, anonymous function, which you are going to store into a reference variable, similar like how you are storing a value to a variable, say int x is equal to 10, and 10 is stored into x. Same way, this is a lambda expression. It is a function implementation, and that function you are going to store into a variable into this in3, and the function you are using here whenever you need. So this is actually the lambda expression, right? Now let us see this example with this, and we are going to see so many other examples with lambda expression. First we will see a small example with this and how it actually works. So here I have a test one, which is having the main method actually, and I'll take a interface in, or you say it is my interface, and which is having a method, say void show is a simple method in this. So first approach, what we did is we have implemented this interface to a class, and I have written the class A, and A class is implementing my interface, and you have to override the show method, so it is void show, and it should be public actually, so it is public, and you just print here it is show method in A class, show method in A, right? So now here in the main method, what you can do is, in the main method you just create, say my interface, my in1 is equal to new A, right? New A, and you can say my interface 1 dot show function, right? And run this and see the output. It is here, show in A. Or if I don't want to use a separate class for implementation and I don't want to do like this, then what I can do is my interface, my in2 is equal to new my interface, and I'll write a anonymous in a class. So this is anonymous in a class, and it is anonymous in a class is from here till this, and inside this I'm writing the implementation of that method, and that is a show method in anonymous in a class, right? Anonymous in a class. And finally here you can tell that it is my anonymous in a class, my in2 dot show, and now you run it and you can say it is this. The same operation by using lambda expression, what you can do is you can say my interface, my in3 is equal to, the function should be stored into this my in3. So normally if I write a function here, say it should be public void show is the function, and it should have any parameter. Currently no parameter, so it is just like this, and I'll write here it is print line, and this is say show in lambda expression, right? So this is how you are creating a function you are going to store into a variable. But in this case, when you are writing the function, the modifier in lambda expression, you no need to write this return modifier, no need to write the return type, no need to write the function name, and here you have to add extra one, this, right? So this is becoming a lambda expression. Very simple, right? So first one is you are taking an extra class, separate class, and you are using that class object here and calling the show function. In the next, you are taking an anonymous inner class and calling the function, and here it is very simple, just a lambda expression like this, and you are saying here my interface 3 dot show. Now you see this is show in lambda expression. It should be printing show in lambda expression. So you just run it and show in lambda expression. So this is actually the lambda expression. A lambda expression is a block of code or a method implementation which you are going to store into a variable, and this is not creating any object. It is not exactly same as this anonymous inner class. It is not an anonymous inner class, and in anonymous inner class what you are doing is you are creating an object of anonymous inner class, and that class object you are storing into this reference variable. But in this, it is not an object of any particular class or any particular type. This is actually a block, a method which is directly going to store into this place. So in this case, if I print this reference variable, see what is the output it is giving here, and it is my interface 2 I'm printing here, and I'll say it is my in2, right? My in2, and see the output. It should give a class name at the red symbol something. So we have already seen in previous sessions where dot class file is going to be generated for this anonymous inner class, and the dot class file name for this should be this test1 $1 and dot class, right? So the class file name for this anonymous inner class should be the test1 $1 dot class, right? So in this, here it is giving the class name, fully qualified class name at the red symbol some hexadecimal value. So here this is com, or I'll give here a colon and some space. Now you print this, it is giving here this. So this is the object, it is object created, and the object type is this. Same way here, if I print say my in3 and give one space and colon and print my in3, right? My in3. Now you will see an output of similar type of this, but actually it is not any class, it is no dot class file name. So it is almost similar type of this, okay, similar type of this, but this is not a dot class file name. It is not going to create any dot class file in your workspace, and it is giving some value here. And later at the end of this lambda expressions, we are going to see how exactly JVM is evaluating lambda expression, how it stores this method into a reference variable like this. So this is lambda expression. Now what are the other ways you can use lambda expression? Like currently this method which you are implementing here in this place, the method is just a show method, and it is not having any argument, even not having any return type. So if a method is having a return type, or if it is having some argument, one argument, multiple argument, and the lambda expression is having a body and all these things, how we are going to implement, and all these things we can see, or so many other things on the lambda expression we have to see, right? So this is just a lambda expression, very simple one. But now, why these lambda expressions are required? What is the use of the lambda expressions, and why it is this much popular nowadays, and why it is used instead of using this type of scenario, instead of using like this, why this lambda expression came? So that use of lambda expressions, and where exactly the lambda expression should be used, and what are the other ways you can use lambda expression, and what are the advantages of all that, these we are going to discuss in the next session. Thanks for watching my video.